This is a video for the second last lesson from Math 30-2 on topic 3, the application of sets. What we've learned so far is some symbols in logic unit. Hopefully remember some of these ones. There's like a U, which means the union. And then there's this one right here, which means the intersects. And so those are symbols that we sometimes correlate them with like the words and. So this is where two things are simultaneously happening. Sometimes we use this one as this one or this one is happening. Other symbols we've learned is if you put a little dash next to it, that's known as a complement. That's kind of the opposite. There's also the empty set, where it's physically impossible. This is the subset symbol. And then there was another symbol where it was like a slash, where it was like A but not B. Some of the symbols we've been working with. And for the most part, we've been just focusing on Venn diagrams. So today's lesson, you'll notice with the notes, it's actually very short. It's only 3 examples. One of the things I need to show you how to do is how to make a 3-direction Venn diagram, where we're going to have not just 2 circles overlapping, but 3 circles overlapping. And the way you solve it is the exact same as the way we've solved the 2-circle overlapping one. If I were to show you kind of a picture of what we have happening here, you would have, say, for 2 circles, you'd have, here's only A. Here's B, where it's kind of the 2 things intersecting in the middle. There's C, and then D is kind of on the outside. So we've done things like this before. We'll write statements like A plus B equals something. We're going to do that same sort of concept here today, only rather than having 2 circles. Let me just erase this just to show you kind of the idea. We're going to have 3 circles overlapping. So we'll have 1, 2, 3 circles overlapping. So I'm going to try to do this as neat as I can. I don't have my little writing board today. Just so you guys know, I'm not feeling all that good over this weekend. I've lost my voice, so hopefully I sound okay over the system here. So let's give these examples a try. We'll see how you do. So first thing I'm going to recommend you do when you recognize that you've got a three-way kind of Venn diagram, you're going to want to draw your diagram. And this even takes a little bit of practice. So I've got the nice circle drawing tool. Here's 1. 2, 3. We need to have them overlap, something like this. And the next thing I would suggest you do is you need to label them as whatever it is we're talking about. So let's see, it looks like we need people who use a cell phone, people who text, which I think are meant to be independent. I think this is an older question. So cell phone is like talking on the cell phone, then texting, and then social networking sites. So I'm going to label one of these ones as a cell phone. Over here, we'll label this one as texting. And this bottom one will use social media. And then what I'm going to recommend we do is we start by just putting letters in for all these spots. So I'll call this A, B, C, D, E, F, G. So what makes this one more challenging than the last time around is that now we have a whole bunch of letters we need to work with. And we're going to be writing quite a few different statements involving how they work. And then it's a big system. It's a puzzle. Remember, this last unit, logical reasoning, is really about puzzles and games. And although, this isn't necessarily the same sort of puzzle as I've been describing some things like, say, playing how to win X's and O's or how to win board games, which we will get to, obviously, as well. This is kind of a puzzle. So let's fill in the information as we best can. So it says 66% of people use a cell phone. And so I'd say the people who use a cell phone is 66%. That would be A plus B plus D plus E equals 66. That would be the first statement that I'd write. And hopefully you'll be able to follow along here. Here's people who used a cell phone. In this section, here's people who only use a cell phone. Here's people who use cell phone and text. Here's people who use cell phone and use social media. And then here's people in the middle, which are kind of probably most people nowadays, who have a cell phone, text on it, and do Twitter in the middle section. So all 4 of these sections, people who use cell phones. Then 76% text. So to write that statement, I would say that would be B, C, D, and F. I think that was 76, did it say? Yeah. Then social networking sites are going to be D, E, F, and G. And I lost where my train of thought was here. Here it is. Social network is 34. You can see this data is probably fairly old. Last time I taught this course. Okay, so those are first four statements, and these ones here, pardon my horrible voice cracking here. These four statements here, they all involve four variables. So we're actually going to work with these ones last because those are the hardest ones to work with. So now I'm going to work on the next statements. It says 34% use cell phones and 56 use cell phones and texting. So cell phones and texting are going to be this little section right here. B and D is where the cell phones and texting overlap. So I'll say B plus D equals, what was that number? 56. Let's see, 56 goes there. Get rid of that guy. Oh, no, did I just delete the whole page? Nope, I didn't. Delete, there we go. Okay. Hopefully you guys are able to follow this. I'm not jumping back and forth too much. The next number is 18% using cell phones and social networking. So 18 is cell phones and social. So that'd be these two numbers right here. That's where they overlap. E and D is 18%. I'll write them D plus E equal 18%. So D and E is 18%. Yep. Texting and social networking is 19%. So texting and social media is D and F. And for the last piece of info we have here, 12% used all three. So the people who use all three, that's right dead center in the middle here, that's D. D equals, I already forgot what the number is. I have such bad memory right now. 12. Okay. So essentially this is a puzzle now to solve. We need to try to fill in every single number here that's sitting there. So, I mean, you guys maybe even can see how to solve the puzzle. First thing I would do is say, look, if you know that D is 12, then I'm going to eliminate D and make D be 12 right there. That's a 12. And once I know that, then I can start working backwards. Like here it says B plus D is 56. So if D is 12, then doing some basic math here, then if I subtract 12 from both sides, I subtract 12 from that, that'd be 44. So B is now 44. Same logic applies below. If D is 12, then I need to take off 12 from 18. So that means that E is going to be 18 minus 12, which is 6. And one more time on this section here, it says D and F is supposed to be 19. So if this guy's 12, then to get F by itself, subtract both sides by 12. So 19 minus 12 is 7. And then now that I have that information, it's almost enough to kind of work on these statements over here and say, well, hey, A plus B plus D plus E is supposed to be 66. So then I start working and say, well, B is 44, D is 12, E is 6. So I just need to work backwards and figure out what that happens to equal. Since I'm not feeling all that well and I don't want to screw up, I'm going to use my calculator. So 66 minus 44 minus 12 minus 6 means that A is 4. And hopefully you don't even need me to do the rest of this. You kind of figure out how to do this. So let's see, what else can we do here? B. So C, we don't know, but B we know is 44. D, it says down there is 12. F, it says is 7. So to get C by itself, take 76 minus 7 minus 12 minus 44. And apparently C is 13. Didn't do that for A yet. A is supposed to be 4. And then for the last one, D is 12, E is 6. F is 7. We don't know what G is. So then we would say 12, let's do it this way, 34, well, minus 12, well, minus 6 and minus 7, G should be 9. Okay, now here's where one of the problems lies here, is that if everything's been done right, hopefully this should add up to 100%. Now I have this nagging feeling that I miswrote a question when I designed some of these questions a few years back, and if I write down any of these numbers down here incorrect, then obviously it won't add up to 100%. But ideally it should. So let's just do a quick double check here. Let's see, we need 4 plus 44 plus 13 plus 12 plus 6 plus 7 plus 9. 4, 44, 13, 12, 6, 7, 9. So here's hoping. It was 95. Okay, here's what that means then. If it doesn't add up to 100, either one of two problems. If it all adds up to 95, then it means that the other possibility is that there are 5 people on the outside. And those 5% of people apparently don't have a cell phone, don't text, and don't use social media, like my grandmother. You know, right? Like, so sometimes that might be the last number they need to kind of figure out. So hopefully I didn't make a mistake, but I just have this nagging feeling. So I guess we'll see as we go through the examples. So, hopefully that made sense. Hopefully we've kind of already built these skills. If you need to, maybe pause the video, watch again. I'm going to do one more example, and I think I'm actually just going to leave the third one for you guys because it's the same concept over and over again. So let's try this one. So it says, well, I don't need to read it out loud. You guys can read. I'll just start by setting up another picture. So circle, maybe not that big. Second circle, third circle. Okay, and again, I find it easiest to label these as A. I don't really think where you put them really matters. I mean, I've now consecutively had D in the middle both times. I might even throw E, F, G, H. I might even throw an H on the outside just to indicate that there is that possibility that nobody does, fit any of these possibilities. I don't know whether we'll necessarily use the H every time, but I guess we'll see. So, yeah, let's start writing out some statements here. 28, have a cat, dog, or bird. So here's where that gets a little bit more complicated here. If you have a cat, dog, or a bird, that pretty much puts you anywhere inside here. So what that means, this is quite the long statement here. But A plus B plus C plus D plus E plus F plus G equals 28 people. Hopefully I can make this fit. Come on. There you go. So if you have a cat, dog, or a bird, I haven't even labeled that. Let's go with this as cat. That'll be dog. This will be bird. So there's cat, dog, and bird. I might have to scroll up and down to make this work. But if you have a cat or a dog or a bird, basically means you're in any of these sections here. You might have a cat and a dog or a cat and a bird. By the way, for notation like this might be something like the number of people who have a cat. I don't know that I can do that symbol that does the upside down one. Let's see what sort of symbols I can do on this thing. Oh, I can too. There we go. Cat or, I'll insert 2 of them. Cat or a dog or a bird. Like that's how you'd notate this sort of thing, right? People who have a cat or a dog or a bird. Let me just hop down here. If you have a cat and a dog only, I mean the number of people who have a cat or you have a dog, but then you'd say, but who do not have a bird. See how that works? So if you have a cat and dog only, you'd probably double bracket actually. Probably write it like this. See how this makes sense to you? So if you have a cat and a dog only, ooh, it says cat and a dog. I used the wrong symbol. I will get this to work. Might take a while. Cat. No, didn't get it to work. Insert. There you go. Okay, so if you have a cat and a dog only, the way you would notate that, by the way, using that symbols we've learned, is this would be the number of people who have a cat and a dog, but who do not have a bird. So, like, if you take off the bird /B, that's your way of notating that, like, you're in the cat and dog only section. Let me just show you what that would be. If you have a cat and a dog only, that'd be right here. B is that cat and dog only section, because D is where you have a cat and a dog and a bird, but we want to have a cat and a dog, not a bird. So, all right, let me keep going here. I feel like I got sidetracked there. So, 13 have a dog. So if you have a dog, dog is B, C, D, and F. B plus C plus D plus F equals 13 people. That was the statement. They have a dog. This person has a dog, this person has a dog, this one has a dog, this one has a dog. 13 have a cat. All right, so that's A, B, D, and E have a cat. We also need to have bird. So if you have a bird, bird is going to be D, E, F, and G as a bird. B, D plus E plus F plus G is 13. Maybe I'll try organizing these statements based on how many different things there are total here. Okay, then it says cat and dog only. And this is being much more specific. If you have a cat and dog only, that actually tells you exactly which one we're doing. The cat and dog only is this one right here, B. B straight up is that number. So there's 4 right here. So I may as well just change that and make B equal 4. Cat and dog only is 4. If you have a dog and bird only, that's 3. So dog and bird only. Dog and bird only would be here. What did I just say that was 3? 2 have a cat and bird only. So cat and bird only is 2. And then lastly, it says that no child has 2 of each type of pet. So basically the way we're trying to say here is I think that was trying to intend that of all the people here, there's that's not supposed to be anything on the outside. So I'm gonna skip that one for right now. But I think when I wrote that question, I was meaning for this H on the outside to be a 0, because I think we have enough to solve now. If I start trying to put some of these statements together, what I can start doing is saying, well, B, everywhere I see a B now is 4. So I'll make that be a 4. I'll make that one be a 4. I'll make that one be a 4, right? F, everywhere I see an F is now a 3. So that's a 3. That's a 3. That's a 3. And E, I should be able to write E as a 2. So that one's a 2. That one's a 2. That one's a 2. All right, so that's what we're looking for, something along these lines here. Now, at this point here, you might be a little perplexed, going, "Okay, hang on, how in the world am I supposed to do this?" Because we seemingly don't have enough information, right? And I'd agree, because at this point here, we actually haven't isolated for any one particular variable. So there's actually a bit of a twist for a question like this. This one's kind of challenging. What we end up having to do is a bit of like a system of equations here. Let me see whether I can try to demonstrate how this works. Do you see how right here in color, there is a C and a D sitting right there? But look, there's a C and a D sitting right there. That's going to be helpful to us. Right, hopefully that makes sense. And then right here, there's an A. And right there is an A. So that's going to help us get rid of that A right there. The problem is there's a D sitting right here. There's an extra D. We don't want that D, but that's okay. Bear with me. Because in the last step is there's a G right here that we need to try to work with as well. But that G actually involves this G right here. It's actually kind of a way that should hopefully make this turn out properly. And so it's going to look something like this if I do it properly. So bear with me. The first thing I'm going to do is I'm going to take this statement right here, and I'm just going to rewrite it. So it used to be, I'll copy and paste it. I'll take this guy right here and say it used to have C plus D. And what I'm going to do is I'm just going to get what C plus D happens to be. So I'm going to have to subtract 3 from both sides. And then I'll also subtract 4 from both sides. So hopefully I can say that C plus D now equals 6. Hopefully that makes sense. And what I'll do then is using this statement here, I'll plug C plus D and I'll make this stuff right here into 6. See how that makes it like a little bit better? It's not perfect, but it's better. Then I'm going to take this statement here. Now, I can't really arrange it in the same way where I want C plus D, so I'm actually just going to get A by itself, just sitting right here. And so if I do that, what will end up happening is I'll have to subtract 2 from both sides, so I'll make that one down to 11. Subtract 4 from both sides, the scale will drop down to 7. And then at this point here, I've got A plus D equals 7. Hopefully that makes sense. The problem here, though, is that I don't have a D in this statement over here anymore to work with. So what I'm going to have to do is I'm going to have to subtract d to the other side and make this guy be minus d. So it used to be a plus d equals 7, but now it's going to be a equals 7 minus d. And that's a little less useful.
Do you want anything from Starbucks or juice?
No, I'm good. Sorry, talking with the wife there. What I'm going to do is I'm going to change out a into 7 minus d. Hopefully that kind of makes sense there. A right here turned into 7 minus d. And I have to do the exact same thing with this last statement here. I'm going to take this last statement here, and I'm going to change it into... Sorry, it's nap time for my girls right now. We're going to try to change this statement into what g is supposed to be. So if I do that, I'm going to take like 2 and 3, that's 5. I'll subtract 5 from the other side. So this guy will now be 8. And then I'll take d and I'll subtract d to the other side and make it 8 minus d. Those are probably the hardest steps there to try to figure out, is how to do all that rearranging. But if you're able to follow that, then take this g right here and make it 8 minus d. And what we've done now is created a statement now over here, and this is probably the hardest thing we do in this section, where now I've wrote this really long equation, and now there's only one letter left. It's d, but d actually shows up in 2 different locations. And the coolest thing about d is if I find out what d is the thing right dead center in the middle. So now I just have to do a little bit of work here. I need my calculator again. So I'm going to take 7, and I'm going to add 6 and 4 and 2 and 3 and 8. And all of these numbers here are going to be 30. So what I could say here is that minus d minus another d plus 30 equals 28. And then what you might do is you might bring the 30 to the other side. And this is where some people get really concerned, because if you bring the d to the other side and bring the 30 to the other side, it actually makes it minus 2. And you might pause, you might say for a second, hang on, that can't be possible. You can't have a negative value here, because you can't have negative 2 people who like birds. But then the cool thing is that the way this works is that when you combine both of these d's right here, you have negative 2 d's equaling negative 2. So when you divide by negative 2, d equals 1. And that's the linchpin. That's the word I like to use for this, the linchpin to the whole thing. Because now that you know what d equals, d is the thing right in the middle. That should give you enough information then to solve for pretty much everything else. So if I work backwards here, if d is supposed to be 1, I should be able to do this in my head. 13 minus 3 is 10, minus 1 is 9, 9 minus 4 is 5, so c is 5. And if d is 1 right here, then 13 minus 2 is 11, minus 1 is 10, minus 4 means a is 6. I don't know that you can hear that in the background, but Cami just woke up from her nap and she's not really happy, so it's a good thing we're just about done. D is 1. So then if 13 minus 3 is 10, minus 2 is 8, minus 1 is 7, that should mean that that is everything we need. Okay. Ideally, it said that all of these things are supposed to add up to give us 28 people. So now let's just do the quick math. Let's make sure that all of these things actually add up to 28. So 6 plus 4 plus 5 plus 1 plus 3 plus 2 plus 7 does equal 28. So now if I answer the final question, if it says how many children have all 3 types, this would be, if you wanted to like write it out, it would be the number of people who have dogs, cats, and birds. And then the symbol we use in between them is if you have all 3 types, it would be an and scenario because you have a dog and you have a cat and you have a bird. So that would be this symbol here. Okay, I'm sorry, I said a little pause there. Cami's waking up from her nap. Okay, this would be the notation here. It would be the number of people who have a dog and a cat and a bird, and we would then say that that is 1 person. Okay, and then if it asks how many children have only 1 pet, where would you only have 1 pet? And I would say people who only have 1 pet would be like, say here, where you just have a cat, or here where you just have a dog, or here where you just have a bird. So that would be the 6 plus the 5 plus the 7. So if you do the math for that, that's 18. So this right here, you would say that it equals, we're back on this slide here, you would say that it equals 18. But then the question would be, well, how do you notate it? And so this one would be one of the harder ones to notate, because we would have to say is we're looking for people who have a dog, but not a cat or a bird. Because that's a person who just has a dog. Then you also want to have a person who has a cat, but doesn't have a bird or a dog. And we also want to have a person who has a bird, but doesn't have a cat or a dog. And we want any of them. So this would be an OR scenario now, where you'd be looking for, wait for it, this is quite the mouthful, eh? You're looking for this. If you only have one pet, there's 3 possibilities. Those possibilities are right here, where you have a dog, but you don't have a cat or a bird. Where you have a cat, but you don't have a dog or a bird. And where you have a bird, but you don't have a dog or a cat. And so that's what this basically says right here. Number of people who have a dog, but don't have a cat or a bird. Or those who have a cat, don't have a bird or a dog. And those who have a bird who don't have a cat or a dog. You got that? That's pretty crazy here. This is something we need to work on is brushing up on your notation in terms of looking at what these symbols mean. So I'll end my lesson there. My kids are getting up from their nap time, so it won't be quiet anymore anyways. So hopefully that made sense. There is one more example, but maybe I'll have you guys try that one on your own, see what you can do with it. I would say usually these 3-way Venn diagrams usually take 2 main methods. One is where you actually get to know the middle number. If you get to know that middle number, it usually means that you can solve for all the pieces very simply. The other one is where you don't get to know that middle number. And we weren't sure about this d equaling 1 number until the very, very end. It was like the last thing we solved for. And it was probably the most challenging thing, because we had to take all these different statements and try to fit them together. And the only way it actually worked out is by having that middle number of d being in there twice. And it usually is pretty common that you end up with a statement where negative 2d equals a negative number. But then once you find that middle one, then you have everything you need. So, okay, I'll pause the video here. Hopefully you guys were able to learn something good from that. The last thing I would suggest is if you try that last example and can figure it out, start working on that assignment. Okay, the assignment is meant to be done tomorrow essentially, and then the day after that we're doing a quiz. So I should be better hopefully by then. As you can hear, my voice is not all that great. So I should be back on Wednesday though. So okay, we'll see you guys soon.